We're now going to talk about inner class listeners. The thing about implementing these listeners and this handling code that we've been talking about is it's very specific to a particular class that's going to be using it. It's not going to be generally used by other classes that you may write. As such, it's almost always going to wind up being implemented right inside of another class, and that would make it an inner class. That is, a class inside of another class, or a class that's nested inside of another class. It's appropriate to do this simply because the code involved is not going to be shared by any other classes, and that's why it makes sense to make it an inner class inside of the only class that's going to be using it. So such a class is called an inner class will only be defined inside the scope of some other class. The advantages of doing this is that it makes your program simpler, and since there's no need for other classes to access it, there's no need to make it an external class, but an internal class or an inner class is a fine approach to use for this. One of the reasons that your programs become simpler when you take this approach is that it's not necessary to use the reference of the outer class to the constructor of the inner class. In other words, the inner class already knows about all the data and methods that are defined in the outer class because it's nested inside, and that means it's a lot simpler to access those things. On this slide, we find a generic discussion of inner classes versus non-inner classes or outer classes or external classes. If we start by looking at diagram A in the top left corner of the slide, you'll see that we have actually two independent classes. The first one at the top is called test and is fully defined on its own, and then as a separate class fully defined by itself is another class called A. Those are two separate classes, and if it turns out that the class test utilizes or uses class A, it's going to have to do so and treat it as an external class. However, in diagram B, under this, at the bottom left corner of the slide, we see a different situation where class A is defined right inside of class test. This is what makes it an inner class. First of all, it's completely inaccessible from outside the class now because it's inside this class. This class is the only class that can see it. That is, the test class knows about class A, but other classes won't. So we would call class A an inner class. Now if you move on to diagram C, which is on the right half of this slide, you'll see that we have taken away the name class A and just called it inner class. And that's because it is an inner class inside of some outer class in this case. Again, this is a generic example, but it's here to show you what advantages result when you locate an inner class inside of some outer class. First of all, take a look at the private data member at the top of outer class. We have private int data. Normally, that is not going to be accessible to other classes, but because this inner class is inside of this class, it has access to it. If you go down to the bottom of this code where you see the section that's highlighted in blue, it's able to access data and increment it. We have the post increment operator on data, so we have data plus plus. We're able to do that. First of all, we don't have to say outer class dot data because we're within the same class, so we can directly use the name of the data member. Furthermore, the fact that it's private is immaterial because we are inside the class, and private visibility does not exclude things from inside the class from seeing it, only things outside the class. Similarly, there's a method that's defined in outer class called M near the top of the slide, public void M. And once again, we have full access to that method. We can invoke it. It happens to be public, but even if it was private, we'd be able to invoke it directly by simply saying M brackets semicolon. So clearly, it's advantageous here to have direct access to all of the methods and data members defined in the outer class inside of this inner class. Now, whenever you compile your programs, a file by the name of your class .class as an extension is always produced, and this will be true for inner classes as well. Just because the class is an inner class doesn't mean it doesn't have to have some bytecode associated with it that the compiler derives, and that will still have to be accounted for somewhere. At the top of this slide, we see the naming convention that's used in general when this happens. There'll be an outer class name and then a $, and then an inner class name .class, and that will represent the bytecode that's compiled for the inner class. So for example, if the inner class name is B and the outer class name is A, then the compiled file will be $B.class. Now more on an inner class. It can be declared to be public, protected, or private and uses the same visibility rules that would apply to a member of the class. We can also declare inner classes to be static, and if we do so, then they can be accessed using the outer class name. In other words, we don't need to create an object of the outer class, but we can just use the class name to access them. If we do this, that static inner class will not be able to access any non-static members of the outer class. It goes without saying that you're going to be able to create objects of an inner class inside of the outer class, but it may not be quite so obvious that you can also do it from a different class outside of the outer class. In other words, it's still possible to access an inner class. If it turns out that the inner class is non-static, then you need to create an instance of the outer class first in order to do that. And the way in which you do that is shown in the middle of the slide here. There's a line of code that says outer class dot inner class inner object equals outer object dot new inner class. So in other words, you need to use that syntax in order to do this. If, however, the inner class is static, then you don't need to create an object because that's how static classes work. In that case, you merely say outer class dot inner class inner object equals, and you immediately go to new outer class dot inner class to do the job.